Welcome, Hornets. In this edition, in this video, I'm going to be talking about operations used in implicit differentiation. For example, we've already talked about just basic differentiation. This is the explicit differentiation, if you recall, where the variable of differentiation matches the variable being differentiated. And we would have 2x dx dx, and this would leave us with simply 2x, since dx is 1. If we have ddx and we do y squared, as we saw in our previous video, we end up with 2y dy dx. And you'll notice this does not equal 1, and so it doesn't go away. We've often seen and used primes, and so some people prefer to look at this as 2y y prime. Now, these are basic, just single monomials. Well, what happens if we have a binomial? What happens if I have x, let's do x squared plus 3y cubed, and I suddenly have a binomial? So in this situation, you'll notice I'm going to go ahead and I'm going to do my derivative. So I have my d dx of the x squared, which we're going to do normally. And then we have our dx of 3y cubed. And we're looking at this one as a chain rule. So as we go, we end up with 2x dx dx plus 9y squared. Notice I'm following the chain rule, dy dx. Now, as we've done, this is our answer unless we want to convert this and just say, this is really 2x plus 9y squared dy dx, or as some people will put it, 2x plus 9y squared y prime. Now, you'll notice this second one has fewer letters. That's why people like it. Instead of having to put that dy over dx, they like to put y prime. Be aware the AP test is going to expect both. So here's a basic operation. We can do this with a sum or a difference. Let's go ahead and take a look at a difference now, and let's do y squared plus y cubed. Notice we can't add these up together, but what we can do is we can find dy dx. So let's take a look at how this works. Chain rule, 2y dy dx plus 3y squared, chain rule, dy dx. Notice they both have a dy dx, so we can factor that out. 2y plus 3y squared dy dx. Now I mention this because there's going to come a point at which we're going to have to use what we know to solve for y. So we have our basic operations here. And you'll notice I'm just distributing this derivative to both pieces. That's our rule. Let's go ahead and take a look at a product rule. Let's say we have 3x squared and we do a y to the fourth. Reasonable. Because this is a product, we're going to be looking at the product rule. So our first piece is going to be u. The second piece is v, and we're trying to construct u prime v plus uv prime. Notice when we have our v prime, we're going to be dealing with the y, and that's the implicit portion. And then we have the u and u prime, and that's going to be our explicit portion. So we have 6x y to the fourth plus, now here it comes, 12x squared y cubed. That's the derivative. And then we add our dy dx. So notice there's always a dy dx. We're going to need one when implicit differentiation. Now we can do all kinds of operations. Let's look at a quotient. Quotient rule. let's take d dx of y cubed over x squared. Quotient rule. Well, according to what I need, we're going to take the derivative of the top. But the derivative of the top is going to have that dy dx in it. So here we go. 3y squared dy dx multiplied by x squared minus the y cubed times 2x, and then we would have dx dx. And this is divided by x to the fourth. Alrighty. Now notice there's an x in common, so we can factor that x, call it 3xy squared dy dx minus 2y cubed all over x cubed. And this is our answer. Thank you very much and have a very good time. I'm going to go ahead and stop this at this point, and I will see you in the next